Hello, welcome everyone. This is ModX Network Voices. My name is Ryan Smith, Washington State University. I am joined by my partner, Ivan Rupnik. Ivan, like to say hello?
Hey, Ryan, hi, everybody.
Thanks for coming, Ivan. And today we have the opportunity to hear from Julian Bowron again. Thank you for coming back, Julian. We appreciate you joining us from Vectorminima. And today it's going to talk about METALOQ. I think that's how it's pronounced, right, Julian?
METALOQ.
METALOQ. Okay,
METALOQ.
great. Julian is an inventor and innovator in the space. Is responsible for technologies in modular construction and had a huge influence. So Julian, please share your screen with us. Tell us the update on METALOQ.
I'd be happy to do that. Here we go. It's working?
Yeah.
Good. Well, so we through the summer we began a setup of a modest but effective manufacturing facility in the main plant of the Walters Group in Hamilton, Ontario, which is kind of our Pittsburgh, Canadian version of Pittsburgh. We have two big steel mills there, DeFasco and Stelco, and a very robust concentration of steel fabricating companies. That can work from coil, slitting, blanking, laser cutting, brake forming, and so on. Walters are Canada's largest and one of North America's best structural steel fabricators. They're responsible for recently the deck at Hudson Yards and a couple of the towers there and so on, and the American Dream project in New Jersey. So they're a major competitor in that space. So they've partnered with us to become our licensee manufacturer and have produced the first kits and the first structure, which I can take you through. So this was assembled just 2 weeks ago. With the amount of practice we got from putting up 6 modules, the last module was set and bolted in 18 minutes from the point that they began to rig it to the point that it was released from the crane and locked down. There's another view of it, just completed on October the 20th. There's a view of a complete METALOQ connection. You can see that at the outer corner, at all 8 of the outer corners of a box of a module, there is a sharp outside corner, and you can see the 4 sharp outside corners there. Are all within a lot less than a 1/16 of an inch in 3-dimensional space from each other, and the extent that they're out at all is actually due to the paint. I was asked if painting would painting be a good idea? And I said, absolutely, because, it would look horrible if the structure was all rusted a short while after it went up. And so we painted it, failing to take into account that this thing is so precise that the paint was an issue. And you can also see that the plane of contact between one layer of modules and the next is perfect and very tight. In fact, as the module went down, it was a very rainy day. The water shot out horizontally, like slapping a puddle, and so testifying to how tight the connection was. We've got the frame incorporates a moment. It's a moment connected in the end walls and braced in the side walls, and here you can really see the robustness of that moment frame running up the center of the structure. The whole structure, and by the way, again, guys, as before, if you have any questions, don't hesitate to ask on the spot. This is the kit of parts that is used essentially to make a METALOQ frame. The horizontal system is light steel framing, roll form sheet metal joists, both in the floor and ceiling. The rim beams are brake formed 1/4-inch steel with the clamp on them, the joist clamp that I'll describe a little bit later. And then the corner columns are 1/4-inch brake formed steel as well. So the parts are all either laser cut and brake formed and welded, or rolled and punched in line. This, just for clarity, is a view of the computer model that shows the connection as it comes together. That's a close-up view of the actual connection. You can see the machined pocket into which the dog bone, as we call it, drops, the horizontal clamp. And you can see also that the units are lifted with a pin that drops into a rectangular hole and is retained from the side by a bolt. So we use one opening for hoisting, for vertical location, and for vertical tension capacity. That shows a magnified view of that dog bone, a model view of that dog bone, and there's an actual dog bone installed. And you can see there the clamping action that provides draws the ends of the base plates together so that there's no space. I mean, they're in tight contact, and you can see the linear displacement. This is at the far end of the module from the first end assembled. And you can see that we have a displacement that is, something considerably less than the thickness of a business card there. So the precision of these frames is very, very high. This is a view for the production nerds out there. This is a view of the welding fixture that I designed and that we built. In fact, Walter's group and I have been collaborating for a long time. They were a prime supplier to me for a number of years, and then we actually joined forces, my previous company and them, and we had built a lot of fixtures during our time there, and this is another one of them that they put together along the lines of work that we'd previously done there. This shows we're locating our components on bolsters monolithically machined from CNC machined from plate. And that's what gets us our very high accuracy. This, so, key concept obviously is fixture fabricated column assemblies give you this very accurate location of frame members, tight control of finished floor to finished floor height. Sorry, if you pause, I got to turn off my phone. I'll give you a countdown to start again. 5, 4. So the use of the fixture to create components of very high accuracy, and you see here the component being welded in that fixture. And by the way, here's the setup of the robot. The honest truth is we didn't use the robot for more than the welding of the central ribs in place. It was really an experimental work with the robot. But the interesting thing is how modest that robot is. So that's a so-called cobot. It does not require all of the non-contact screening around it and so on, the safety net around it, because it can actually, like a smart car, tell that if something is too close, and in fact, if anything touches it, it'll just stop. So the only issue you have to really deal with is arc flash. Then on the floor system, we're extremely proud of the floor system here. So we have, the issue with light steel framing is that connecting it to the rim joists is typically done with a light little sheet metal angle and a whole pile of tech screws. And those connections are notoriously low in fixity in anything other than the vertical shear axis. So what we've done here is we actually dimple the web of the joist and clamp it between a component welded to the rim joist and a loose clamp. So this shows actually the tooling of that first dimple. I made this in my garage. Got a nice little workshop in my garage. And this shows a stack of the iceman joists dimpled with the correct dimple feature. And this shows them installed in the module. The neat thing about this is we were able to knock more than 1,000 pounds out of the weight of the frame by using the floor joist as a main component of the module structure instead of being simply an infill component. So these create the horizontal spacing of the module. They have very substantial moment action, all of the required shear in the vertical plane to give the floor solidity, and so on. So this has really, really helped. We were able to pick up modules from the center only, throw a lot of compression on the ceiling joists, and no no distortion, no buckling, nothing. So this is really quite a success. The idea, of course, is that as I think maybe people are starting to become aware of this, the idea is that we make these kits in a plant. Well, Walters makes these kits in a plant, and they ship to a site, either the job site directly or to a modular manufacturer who does not then need to make frames, and they are knocked up, as you see here, to make the frame of the module. So we're also very proud of the fact that this is really liberating for modular builders who want to get into non-combustible frames. They don't have to set up to do any metal fabricating. They just buy these, put these together, and away they go. And by the way, the assembly time, it took a little bit less than 2 hours for essentially, I would say 5 people to put these together using an overhead crane. And in fact, the overhead crane is probably not even the most efficient way to do it. I think, genie lifts or a forklift would be even faster. I think the benefits of precision frames are starting to become increasingly self-evident in the industry. Having something that's self-squaring and, where you have a perfect structure with no laborious surveying and everything else required to put the thing up is a big advantage. This structure, the frame and the structure went together without the use of any tape measures, plumb bobs, levels, survey instruments, anything other than for the base. So, and the structure is startlingly perfect. We've confirmed that it's solid as hell. We had a guy up in one of the iron workers was up in the cherry picker and trying to shake the top, and it doesn't shimmy or anything. Obviously this is all math based, but it's always nice to get that confirmation. So we're hovering, that frame is hovering in the 12.5 pounds a square foot range. And interestingly, in the last couple of days, we've come out with some pricing. So with our relatively low volume tooling setup, supplied out of Walter's plant in Canada here, we're looking at about, in reasonable quantities, something just a little north of $11,000 a frame. So, that's directly, well, it's aggressive, even in comparison to ocean freight containers and so on. And by the way, that's a 350 square foot frame. So we're very happy with the initial pricing. We're very happy with the initial material efficiency. It's looking pretty good. There you go.
That's great, Julian. Where are you at right now with commercialization of this product, and as it relates to like testing and code compliance? Where's that at currently?
So this is, very early going. Clearly, we've demonstrated the viability of the structure. It was easy to make, easy to assemble, and easy to erect. We have a lot of work yet to be done. From a fireproofing viewpoint, interestingly, using the I-span as the floor joist, and we're using the mega board as the decking, which is the one of these magnesium oxide board products, or if we were to use, say, Structocrete from USG, there is an abundance of testing, full-scale testing and certifications for that assembly. So we're currently, we expect that in a number of jurisdictions and a number of applications, the existing certifications for the assembly consisting of I-span or SureSpan or some other off-the-shelf light steel frame joist, and decked with Structocrete and so on will be compliant. So the other challenges are, of course, all the fire sealing around all of the penetrations and so on. And again, that is, relatively off the shelf. That's kind of stock and trade stuff at this point. So we're not seeing our customers having a particularly challenging time getting building permits for structures built in this way. We are going to do a robust program of destructive testing. We're currently determining what institution we're going to work with on that. We've been approached by a number of universities and some of which have programs even specializing in the modular industry. And there's likely an announcement coming on that front shortly. So yeah, there you go. And luckily, as I think everybody knows, there's a tremendous interest in modular construction on both sides of the border right now. The federal government here just gave $1 billion, including $200 million to Toronto for rapid build housing and so on. And in general, people are looking to modular construction to fulfill that need. So so we believe that the support that we need as a company in order to continue our program of development and testing is not going to be terribly difficult to get.
It's great to see this is the kind of 2.0 of some of the work you've already done in the space. Are there things that you learned from your last system that have changed, or is this a different? How is this pivoted? What are some? Are there things that have intentionally changed based on that experience?
Well, I was with the Walters Group. I'd sold my previous company to them when we did the modular scope on the Bow in Calgary. So I set up a modular facility for them and executed that scope as Feature Walters, the special projects division of the Walters Group. And so that's where I started my work in modular construction. Prior to that, we had focused on off-site, which inevitably required us to make what I refer to as an interface frame between the fuzzy stuff, the drywall and kitchen cabinets and everything else, and piping, and the hard stuff like the foundations. And so that's where it all got started. This system is very, very much a completely fresh start. Like, as you see, the entire structure is light steel framing. There's no use of so-called long product, so there's no channel, there's no I-beams, there's no angles, there's no hollow steel sections. All of the parts are executed from programs. None of them are from hard tooling, other than the welding fixture for the column assemblies. So, and then the whole structure is bolted at all of the connections. It's not a welded structure. And furthermore, it's supplied as a kit. Yeah,
that seems
there you go. And by the way, from a business model viewpoint, this is a very, very different project than any I've been involved in, because this is strictly an intellectual property business. So we're not actually making anything. We license Walters and we will license other companies and modular builders to use this system. We do not intend to be a manufacturer or a developer or a builder or a turnkey modular provider. That's not our intention. Our focus is on the intellectual property needed for modular construction.
So following up with that, Julian, also, I think that the idea of doing a kit of parts frame is brilliant. We've seen that in Japan, and the Sekisui Heim actually basically orders it's a different approach, but it's like H steel, and it's a frame that comes to their factory from another manufacturer, from a steel manufacturer. On the other hand, we've seen that steel modular in the US has often been set up near large cities, which means the facilities are small, and often the frames, so full stack, Skender, but also even smaller operators are having to ship entire chassis from fairly far away into cities, store them. So there's all kinds of issues that I think a kit of parts is a pretty brilliant solution. I guess I would ask, have you thought about the production of this what do you call it? The fluffy stuff,
the fuzzy stuff.
The fuzzy stuff. How does the assembly logic of this, is this basically a chassis that you fill out however you want, or have you thought a little bit about the efficiencies built into this? Can you panelize this before you assemble it? Are there ways to think about other assembly processes for the interior finishes, for insulation? And how does that system anticipate that production process?
So, well, very good questions. Excellent questions, actually. I was on the phone through the morning with an industrial automation supplier who has some experience in this area of business, and so it is definitely possible to panelize these structures. One could theoretically assemble the ceiling and or the floor independently and then join them to the columns. One could also assemble a sidewall with the columns and the floor and the rim joists, and assemble them to the floors and ceilings and so on. We've conceived this product to fill the requirement of a mid-sized, small to mid-sized modular builder for whom it would be most practical to simply assemble a frame and then start fitting it out as a complete volume, and probably in a bay approach rather than an assembly line approach, though these could certainly go on an assembly line. So, you know, the key thing here is delivering a precision volume into which people can dependably work without fear of, you know, difficulty in the stacking process, and so on. So that is our, you know, that's how we see our end users taking advantage of this concept. Right.
You know, it's not unlike our recent conversation, Ivan, with Jamie Johnston at Bryden Wood Architects. You probably have seen that, Julian. And over the years, you know, they had a factory where they were prototyping for a number of years. They've stopped manufacturing now and gotten back into sort of design and invention game. But it's a kit of parts approach, in many cases using either hot rolled or cold formed steel for different building types. It's an interesting approach, and something that they've done is color coded all of their parts so that if a factory can easily put it together with unskilled labor. You cannot make a mistake in the way you put this thing together. And so that's a question I had for you, is if you thought about the assembly logic for a factory, or how you gain that skill set as a factory line worker in order to know how to put this together. I'm sure it's pretty simple with the dog bone connection, but maybe just more about that.
So every part in this kit, at the point that it goes under the laser or in the CNC mill, has a part number machined onto it, is number one. And so the parts are very easily identifiable that way at all phases in the production process. And secondly, you can only put these together one way. There isn't there isn't really a way of getting it wrong. And thirdly, we've created an exactly like an IKEA assembly manual, which leverages the SolidWorks model, and the parts are turned on one at a time in the correct orientation for assembly and so on. So and by the way, these frame kits that went together in about 2 hours, that crew had self-evidently never done these before, because these are the first 6 that have ever been made. And they were not particularly skilled in this particular area of work. They were, people from the maintenance department of the company, shop floor welding people and material handling people and so on. So they were not expert iron workers. It was expert iron workers that rigged, hoisted, and placed the modules. And Walter's group and myself, I mean, we think like that. That just makes sense from a safety viewpoint. You don't want to, no matter how foolproof the whole process is, you want to use and you'll note in this image, by the way, the fellow's tied off correctly, and et cetera, et cetera. And actually, there's a guy on the bottom end of the ladder, and so on. So
there's a lot of intelligence you've put into this, Julian, in the front end, in the design for manufacturer. And I just wondered, if we think about the supply chain, we just spoke about sort of the modular manufacturers assembling these products in the downside of the supply chain. How about the upside or the top of the supply chain in design decision making? How do the architects and engineers, design architects and engineers, engage with this, or how do you envision that happening so that they know how to put their projects together with the system?
So SolidWorks, so we use SolidWorks for the design of this product, and so the SolidWorks is readily able to export models that can be used within Revit, and within all of the other commonly used architectural design programs. And so we, what we've been doing with the very limited number of engagements we've been involved in so far, because this is so very new, is we have simply exported a SolidWorks, a Revit compatible model to the architect, or in the case of architects that work in SolidWorks, or its parent, which is CATIA, they can import the native model. And then the model has quite a bit of intelligence in it. Of course, it can, it can accordion, it can be made longer and higher and wider and so on quite readily. But from that point, we leave it to people to, to design and engineer these in the way that they best see fit. So, the system, I'm proud of the fact that the system is relatively easy to work with. The penetrations through the floor are extremely straightforward. Thermally it's effective and so on because of the, these exposed sections spacing out, really, you can pack them all with insulation and so on. So it isn't terrifically difficult for somebody to work with this system. And of course, in terms of the amount of footprint that it takes up, it's also quite minimal. So, there it is. By the way, we've used as the basis of design here, that very common 350 square foot, 13.6 by 28 by 9 inside size that, has been, so popular in terms of demand. That's predominantly what companies like Gurdon are building, and so many others are hotel rooms of that basic dimension. So that's, I guess, another point to the immediate applicability is that the basis of design here is a common proportion.
But Julian, just to clarify, because your business model, you described, selling these basically directly to modular manufacturers and replacing their need. Well, and they're often buying steel chassis from someone else anyway. Mm-hmm. But then you're also describing that the sort of engineering process happens through an architect with what is still fairly, unfortunately for the industry, still fairly rare software setup for many of the modular manufacturers we've seen. So is this an architect? So I guess I'm trying to understand, a developer architect team, obviously, that may have access to the software, making a decision about this system versus and then really pushing a modular manufacturer in this direction, or a modular manufacturer sort of offering this, building sort of their entire sort of manufacturing logic around the access to this as a sort of standard product. Who do you think is going to be driving the demand, and is there going to be bottlenecks in terms of knowledge and scope?
The question is very well put. So as I think everybody's abundantly aware, the price of lumber is going through the roof, and the price of steel is not. And so there's been a big closing in the gap between wood framed and steel framed construction, is number one. Number two, all of these wildfires and the resilience issues that so many communities are facing are mitigating heavily in favor of steel. Number three, the claims made by the wood products industry with regards to their sustainability and so on, are coming under increasing scrutiny. Like I'm by the way, the ultimate tree hugger. I have 125 acres of bush and a mile of a river, and et cetera, et cetera, et cetera. I'm more of an extreme tree hugger than most, and I recognize that shaving a forest bald and turning it into mass timber construction, may not actually be solving the world's problems. Wiping out mature forests, maybe not such a great idea. So, or even immature forests, monoculture forests. So I think there's an increasingly vigorous debate about what materials are being used, and that's driving a certain amount of decision making. And then secondly, we're certainly hoping that we see our principal potential future clients as the wood-based companies who need something that looks, feels, and tastes very much like what they're already doing.
Right.
And that is this, it's everything you screw to inside this thing is light steel framing. So, the inexperienced carpenters, the steel stud inexperienced carpenters that we sent in to put the megboard floor into this module, which is now in, had no issue doing it. There was only 2 bad screws in the whole 750 square feet with those stand-up auto feed screw guns. And there you go. Like it wasn't hard for them to wrap their heads around it at all. So
but I guess to that point, which is a really interesting idea, that there's 200 plus modular manufacturers in the U.S. and Canada, and that they already have an established.
Wow, well, I had no idea.
That's a rough estimate, but that they all have a certain production system, and that you would replace the framing with that's a great way to understand where you're going. In those cases, though, right, just in the nature of lightwood frame construction, it's less engineered and more rule of thumb. It's more there are sort of standards, which also is what makes the production a little more rapid, as opposed to steel, where there's the kind of design time and engineering time is much higher. Would you see then that this product might through relationship with the government, would it have some kind of, in some cases would be pre-approved structurally? Is there ways so that you can cut that time and that decision-making process?
Certainly that would be an ambition of ours, would be that that sort of statewide or countrywide certification. Some jurisdictions are far better organized to do that than others.
And Canada in general.
Well, by the way, Singapore, Singapore is good at that. The UK is good at that. Germany is good at that. And yes, you're right. In Canada, we tend to have national agencies. That, as you may well be aware, the Canadian Standards Association, the CSA, is currently writing a standard for modular construction. And in fact, we have multiple eyes into that. The lead project manager on this project is instrumental in that effort. And so we're hearing about it every day. They've published a preliminary report. It's very interesting. Part of a big chunk of the business model of our business model is to have customers, and to have those customers help us get through all of that via the fees that they pay to us and their expertise. So, we're looking to partner strictly with senior firms that are well experienced and have, knowledge already in areas like certification and so on, and have some understanding of the process. We're not anxious to start from scratch on all fronts simultaneously. We certainly want to try to leverage the existing knowledge base of the companies we hope to become customers. So.
Julian Bowron, thank you for joining MODEX Network Voices today from Vectorminima and his new product, METALOQ. Really appreciate you coming and sharing your knowledge, and we hope that this will help for some of the uptake and trying to help modular construction move forward. Thanks for your time.
You're very welcome. Thank you guys for giving me the opportunity to do this. Keep up the good work.
Thank you, Julian.